In this video I'm going to prove from first principles that the derivative of cosh x with respect to x is sinh x. So we know from first principles that the derivative of cosh x is the limit as delta x approaches 0 of cosh of x plus delta x minus cosh of x all over delta x. And we know cosh x is e to the x plus e to the minus x over 2. So this becomes the limit as delta x approaches 0 of e to the x plus delta x plus e to the minus x plus delta x over 2 subtract e to the x plus e to the minus x over 2, and then this is multiplied by 1 over delta x. And so combining these fractions gives the limit as delta x approaches 0 of, take out a factor of a half from both, then we get e to the x plus delta x minus e to the x plus e to the minus x plus delta x minus e to the minus x, and we can put this all over delta x, and then this is the limit as delta x approaches 0 of a half times e to the x plus delta x minus e to the x over delta x plus e to the minus x plus delta, oh there should be an x there, plus delta x minus e to the minus x over delta x. Now we know from first principles that this is just the derivative of e to the x, so this will become the limit as delta x approaches 0 of a half times e to the x, and this is just the derivative of e to the minus x. Now if we apply the chain rule to that, we get that the derivative of e to the minus x is going to be minus e to the minus x, because the derivative of minus x is just minus 1. So if we put that in, we're going to add this derivative, so add minus e to the minus x, which is just the same as subtracting e to the minus x. Now there are no terms in delta x, so we can just remove this limit, and we get e to the x minus e to the minus x over 2, which is just sinh x. And so we're done. That's all for this video. Thanks for watching. If you have any questions or video suggestions, leave them in the comments below, and if you want to see more content like this, subscribe now.